వెల్కమ్ బ్యాక్ టు శ్రీ వెంకటేశ్వర ఇన్స్టిట్యూట్ ఆఫ్ మ్యాథమెటిక్స్ యూట్యూబ్ ఛానల్. సో నిన్నటి వరకు మనం ఫస్ట్ చాప్టర్లో ఎక్సర్సైజ్ 1.1 కంప్లీట్ చేసాము. 1.2 ఎక్సర్సైజ్కి వెళ్ళే ముందు ఒక 2 ఎగ్జాంపుల్ ప్రాబ్లమ్స్ ఉన్నాయి. వాటితో పాటు ఎక్సర్సైజ్ 1.2 స్టార్ట్ చేయాలంటే కొంత ఇంట్రడక్షన్ అనేది మీకు అవసరం. సో ఆ ఇంట్రడక్షను లెట్ మీ ఎక్స్ప్లెయిన్. సో నెంబర్స్. సో మనం నెంబర్స్ అని చెప్పినప్పుడు ఇందులో సో మెనీ టైప్స్ ఆఫ్ నెంబర్స్ వీ హ్యావ్. న్యాచురల్ నెంబర్స్, హోల్ నెంబర్స్, ఇంటీజర్స్, రేషనల్ నెంబర్స్, irrational numbers. Okay, yes, actually numbers had been divided into 2 parts. That 2 parts are nothing but, listen to me, numbers are divided into 2 parts. So the name of first part of the numbers is real numbers. Real numbers, they are represented by capital R. Next, after that, non-real numbers. Non-real numbers, they are also called as imaginary numbers. Imaginary numbers. So these imaginary numbers are represented by R dash. Okay, that's all. Again, rational numbers are divided into 2 types. What are they? Sorry, not rational numbers. Real numbers are divided into 2 types again. They are, the first one is rational numbers. Rational numbers. So these are represented by Q. After that, irrational numbers. Irrational numbers, they are represented by Q dash. Okay, yes, in these rational numbers, some types of numbers, that means which we have been learnt in previous classes, that all set of numbers will come into the rational numbers. What are they? So first, integers. Listen to me, all integers are rational numbers, but all rational numbers are not integers, because of whatever the integers you have been taken, they are in the form of just only direct numbers. So integers are not in the form of rational, that means p by q form or fractional form. Okay, so whatever the integers you have been taken, that each integer it is possible to write as in the form of p by q. That means there is no denominator for all integers. In such cases you can take 1 there. In such way, these all integers are nothing but rational numbers. In that way we can say. So after that, but all rational numbers are not integers, because of all rational numbers means so if you take 2 by 3, it is a rational number, but it that number should not be in the integers. So that's why all integers are rational numbers, but all rational numbers are not integers. Yes, after that we need to take whole numbers. Whole numbers. So integers are represented by capital Z and whole numbers are represented by W. Now listen to me, all whole numbers are integers, all whole numbers are rational numbers, but all integers are not whole numbers, because in whole numbers we are having negative numbers also, but in whole numbers we won't have the negative numbers. In that way we can say all whole numbers are integers, but all integers are not whole numbers. Next, all whole numbers are rational numbers, because of whole numbers are starting from 0 up to infinite. Okay, 0, 1, 2, 3, 4, 5 and so on, like in that way you can write. 0 you can write as 0 by 1, 1 we can write as 1 by 1, 2 we can write as 2 by 1, 3 by 1, 4 by 1, like that. In that way we can write. So here all whole numbers are possible to write in the form of p by q. That's why all whole numbers are rational numbers, that's all. But here all rational numbers are not whole numbers, because of rational number. If you take one as example as minus 5 by 3, I am taking this minus 5 by 3 is in fractional form. The numbers which are in the form of fraction, they are not in whole numbers. So due to that reason, all rational numbers are not whole numbers, that's all. Next, after that, we need to consider natural numbers. Natural numbers. So these natural numbers are represented by capital N. But natural numbers start from 1, 2, 3 up to infinite. So here all natural numbers are whole numbers, like in that way we can say, is possible to say in that way. And all natural numbers are integers, it is also possible to say. All natural numbers are rational numbers, it is also possible to say. But all whole numbers are not natural numbers, because of in whole numbers we have 0. 0 is not in natural numbers. Due to that reason, it is not possible to say all whole numbers are not natural numbers, that's all. Next, all integers are also natural numbers, because of in integers including 0 all negative numbers we have. But in natural numbers we won't have that 0 and negative numbers. Due to that reason, it is not possible to say all integers are natural numbers, that's all. Next, all rational numbers are also not natural numbers, because of the numbers which are in the form of fraction, that all belong to rational numbers. But the numbers which you are taking in fractional form, they won't, that means they should not be in natural numbers. Due to that reason, it is not possible to say all rational numbers are natural numbers, that's all. Yes, let me explain one more time. So actually numbers are divided into two types. So one is real numbers represented by capital R, and another one is non-real numbers. They are also called as imaginary numbers or dash. Okay. Again, real numbers are divided into two types of numbers. So what are the names of the two types? Is nothing but rational numbers represented by capital Q and irrational numbers represented by capital Q dash. Next, so here integers, whole numbers, natural numbers, these all types of numbers will come into rational numbers, that's all. Here all natural, for example, if you take rational numbers and integers, all integers are rational numbers, but all rational numbers are not integers. Next, all whole numbers are integers, all whole numbers are rational numbers, but all integers are not whole numbers, all rational numbers are not whole numbers. ఇందాకే వాటి గురించి ఎక్స్ప్లెయిన్ చేశారు ఎందుకు కావు అని. నెక్స్ట్, ఆల్ న్యాచురల్ నెంబర్స్ ఆర్ హోల్ నెంబర్స్, ఆల్ న్యాచురల్ నెంబర్స్ ఆర్ ఇంటీజర్స్, ఆల్ న్యాచురల్ నెంబర్స్ ఆర్ రేషనల్ నెంబర్స్, బట్ all rational numbers are not natural numbers, all integers are not natural numbers, all whole numbers are not natural numbers. Next, here one more thing we need to consider. Here irrational numbers, they are represented by Q dash. So in future classes you may get about the irrational numbers, about them. Okay, I can explain about these irrational numbers in future classes. Okay, yes, note down them. Yes, let me explain about decimal fractions. So the definition for the decimal fractions is the fractions which are having their denominators as 10, 100, 1000, 10,000, and so on are called decimal fractions, సో ఏ ఫ్రాక్షన్స్ యొక్క డినామినేటర్స్ అయితే 10, 100, 1000, 10,000 and so on ఇలాంటివి ఉంటాయో వాటిని మనం ఏమని పిలుస్తామంటే డెసిమల్ ఫ్రాక్షన్స్ అంటాం. సో వీటికి ఎగ్జాంపుల్స్గా 1/10, 25/1000, 308/100, 1256/10,000. Like in that way we can take as their examples. That's all. Yes, next come to the concept of decimal forms. So that means the numbers which are able to write by using the decimal point, they are called decimal forms. The numbers which are eligible to write the numbers which are eligible to write by using the decimal point, by using the decimal point are called decimal forms, are called decimal forms. Example, yes, 23.756 comma, next 0.713 comma, 235.010101 and so on. Next 234.71325 and so on. So these type of all numbers we need to call as decimal forms. Okay, yes, here we need to know about the types of decimals. Here decimal fractions, actually three types we have. What are they? So first one is terminating decimal, and second one is non-terminating repeating decimal, and third one is neither terminating non-repeating decimal. Here a repeating word had been replaced sometimes as recurring. So repeating and recurring both are same. Okay, so now listen to me. Decimal forms are three types. They are, first one, terminating decimals. Terminating decimals. So example for these terminating decimals are 0.235, 111.236, next 17.1415, that's all, and so on. These type of decimals we may consider for the example of type of terminating decimals. Next, second one, non-terminating repeating. Repeating we may call as in this way also, that is recurring. Recurring decimals. So example for non-terminating repeating decimals or recurring non-terminating recurring decimals, they are 735.0125, 0125, 0125 and so on. Next 301.35, 35, 35 and so on. Next one more example, 101.73125, 73125 and so on. These type of decimal fractions are example for the type of non-terminating, repeating or recurring decimals. Okay. Yes sir. One more type we have, third one, that is third type, non-terminating, non-repeating or recurring. So in this way also you can write this type, neither terminating nor recurring, neither terminating nor recurring. That's all. Okay, listen to me. I am giving some examples for this type. These are 3.140, 1400, 14000, 14, comma, no, not comma is there, and so on. This is one example for this type. One more example, 1.4132, 0413, 041320, 561432 and so on. This is one more example for this type of decimal. And one more example I am taking, 125.001, 0001, 32, 56, 401 and so on. That's all. So these are three types. Just listen to me. Here in this chapter we are having three types of decimals. They are terminating decimal one type. So example for this terminating decimals are nothing but we have been given here. And second type is non-terminating repeating. That repeating word we may replace by using the word recurring also. So this type of name is non-terminating repeating decimals or non-terminating recurring decimals. So here also I am giving some more examples for this type of decimals. Next, after that, finally one more type, that is non-terminating, non-repeating or recurring, like in that way we may call. Next, this type of decimals also we can call as neither terminating nor recurring decimals. Okay. Yes, here also I am giving some more examples for you. Listen to me. Here if you observe, 140 is repeating, but this 140 is not repeating in a particular order. Okay, that's all. Next, 1.4132, 413, 4132, 4132. So here also 4132 is repeating, but it is also not particularly repeating. Next, 125.01, 0001, 3256, 401 and so on. So here also the digits are repeating. What are they? 001 one time, 0001 in another time, and 4071. This is also repeating in a non-particular order. So that's why these type of decimal fractions are called non-terminating, non-repeating, recurring or decimals. So this type of decimals also called as neither terminating nor recurring decimals. Okay na? Yes. ఒకసారి ప్రాబ్లమ్స్ వేసుకోండి. నెక్స్ట్ టాపిక్ వెళ్దాం. Yes, let me explain the problem. That is, represent the following fractions into decimal forms. ఈ ఫ్రాక్షన్స్ని డెసిమల్ ఫామ్స్లోకి కన్వర్ట్ చేయాలా, బట్ వీటిని నువ్వు డెసిమల్ ఫామ్స్లోకి కన్వర్ట్ చేయాల్సిన అవసరం లేదు, బికాస్ ఆఫ్ ఆల్రెడీ దే ఆర్ ఇన్ డెసిమల్ ఫామ్స్, దట్స్ ఆల్. అండ్ ఆల్సో సే దే బిలాంగ్ టు విచ్ టైప్ ఆఫ్ డెసిమల్, ఈదర్ టర్మినేటింగ్ ఆర్ నాన్ టర్మినేటింగ్ రిపీటింగ్ బార్ రికరింగ్, ఆర్ neither terminating nor recurring bar నాన్ టర్మినేటింగ్ నాన్ రిపీటింగ్ అని చెప్పాం. అంటే ఇక్కడ ఏం చేయాలంటే ఫస్ట్ అండ్ సెకండ్ ప్రాబ్లమ్స్లో ఇచ్చినటువంటి ఫ్రాక్షన్స్ని ఫస్ట్ డెసిమల్ ఫామ్స్లోకి వేయాలి. వేసిన తర్వాత ఆ డెసిమల్స్ ఏ టైపు, టర్మినేటింగ్ డెసిమల్సా, నాన్ టర్మినేటింగ్ రిపీటింగా, నీదర్ టర్మినేటింగ్ నార్ రికరింగా అని మనం ఫైండ్ అవుట్ చేయాల్సి ఉంటుంది. ఓకే, సో ఇందులో నేను ఫస్ట్ ప్రాబ్లంలో ఇచ్చిన 3 ఫ్రాక్షన్స్ తీసుకుంటున్నా. 1/2, 1/4, 1/8. So first I am going to write the decimal form of 1/2. To represent that 1/2 into decimal form, we need to divide 1 with 2. So the division is not possible because of this dividend is less than the divisor. In such cases, we may put 1 point in quotient part. Then you can promote 1 0. Yes, now 2 5s is 10. Now listen to me, here there is no integral part. In such cases you can take 0. So the decimal point of the decimal fraction of 1/2 is 0.5. Yes, here if you observe the remainder, it had been ending with 0. So the divisions, that means in the divisions which are ending with 0, in such cases the quotient part which you are obtaining, they are called terminating decimals. So this fraction belong to terminating decimal, that decimal is 0.5. Next, second one I am taking here, 1/4. Here also we need to divide 1 with 4. So same thing, that dividend is less than the divisor, so that's why we need to put 1 point here, and we can promote 1 0. And now 4 2 is 8, the remainder is 2. So due to this point, always you can promote 1 0. Yes, 4 5 is 20. Now here also we can put 0. So the decimal form of this 1/4 is 0.25. Next, third fraction I am taking, that is 1/8. Now listen to me, here also we need to divide this 1 with 8. So here also dividend is very less than the divisor. Due to that reason, we can put 1 point in quotient part. Then you can promote 1 0. 8 1 is 8 will cancel, 2 is the remainder. Next, after that, due to this point, one more 0 we can promote. Now 8 2 is 16 will cancel. So now the remainder is 4, and due to this point one more 0 we can take. Now 8 5 is 40. There is no digit in integral place or in this place. There you can promote, you can take 0. So the decimal form of 1/8 is 0.125. So listen to me, here in these 3 divisions, these all divisions are ending with remainder zeros. Okay, whenever the divisions are ending with remainder zeros, in such cases the decimal fractions which you are obtaining, that all decimal fractions are called terminating decimals. So listen to me, 0.5, 0.25, 0.125 are terminating decimals, or terminating decimals. That means these fractions represent terminating decimals. Okay, therefore given fractions, what are they? 1/2, 1/4 and 1/8 represent which type of decimals? Terminating decimals. Terminating decimals, that's all. Okay, so complete this work on the board. I will go for second problem. Yes, now come to second problem. 1 by 6, 1 by 3 and 2 by 7 and 1 by 11. These are also called fractions. These fractions also we need to convert into decimal forms. Yes, now listen to me. So here ఈ ప్రాబ్లం ఒక్కటి మీరు హోంవర్క్గా పెట్టుకోండి, రిమైనింగ్ 3 ప్రాబ్లమ్స్ నేను చేస్తాను, లేదా దీన్ని హోంవర్క్గా పెట్టుకోండి, ఈ రిమైనింగ్ 3 ప్రాబ్లమ్స్ నేను చేస్తాను. ఓకేనా? రైట్. ఇప్పుడు చూడండి, 1 by 6 that is equal to, now we need to divide 1 with the 6. This dividend is less than the divisor. Due to that point you need to put one point in quotient part, then you can promote 1 0. How many times it will cancel means 1 time. 6 1 is 6, the remainder is 4. Due to this point you can promote 1 0. Now 40 you are getting, so now we need to divide this 40 with 6. 6 6 is 36, next 6 7 is 42, so that's why 6 6 is 36 we need to take. Yes, 4 and 0. Now how many times it will cancel means again 6 times. 6 6 is 36, 4 0, 6 6 is 36, 4 0, 6 6 is 36, 4 0, and so on. Like that you need to write, because of that division is not ending and 6 is repeating. It is very clear to us. Okay, so here we can write this one as 0 point. That means there is no integral part. That means left side of digit, if you haven't to get any number there, in such cases you can take 0. 0.1, 6 6 6 6 and so on. That's all. Okay, now listen to me. Here if you observe this division is not ending. That means it is not getting remainder 0. Such type of decimal fractions in such cases which are obtained, they are called non-terminating repeating decimals. Non-terminating, why you are using that word means division is not ending, so non-terminating. And digits are not ending in quotient part, they are repeating and repeating in a particular order. So that's why we are using the word non-terminating and repeating digits. Repeating word is also replaced as recurring. That's all. So division is not ending, that's why we need to use the word non-terminating. Next, so the digits are repeating in a particular order, so that's why you need to use the word either repeating or recurring. That's all. So this type of decimal is nothing but non-terminating repeating decimal. Non-terminating repeating decimal. Next, 2 by 7. Here also we need to divide 2 with 7. So here also 2, the dividend is less than the divisor. That's why I am putting one point in quotient part. You can take 1 0. 7 1 is 7, 7 2 is 14, 7 3 is 21. That's why you need to consider only 7 2 is 14. The remainder is 6. Okay. Now due to this point you can take 1 0. Next 7 8 is 56. The remainder is 4 and 0 due to this point. Next, how many times it will cancel? 7 5 is 35. The remainder is 5. Due to this point you can take 1 0. How many times it will cancel? 7 7 is 49. Remainder 1 0. How many times it will cancel now? 7 1 is 7. Remainder 3 0. After that 7 4 is 28. Remainder 2. Due to this point you can promote 1 0. And after that 7 2 is 14, 6 0. 7 8 is 56, 4 0. 7 5 is 35, 5 0. 7 7 is 49, 1 0. 7 1 is 7. Remainder 3 0. 7 4 is 28 and the remainder is 2. Yes, 10 7. Now the remainder is 3. Due to this point one more 0 you can take here. How many times it will cancel now? 7 4 is 28. What is the remainder? 2. So if you observe the digits 2 8 5 7 1 4, 2 8 5 7 1 4, after that also you can get 2 8 5 7 1 4. So here the remainder is nothing but 2. So that means division is not ending here. So whenever the division is not ending, you need to use the word non-terminating. Okay, yes, non-terminating. But here the digits are repeating in a particular order, 2, 8, 5, 7, 1, 4. After that again you are getting this frame 2, 8, 5, 7, 1, 4, and after that this frame again and again we are getting. So that's why you need to use and so on. That means due to the reason of getting a non-ending division, this decimal fraction is called non-terminating repeating decimal. That's all. Okay. Yes. 0.124, sorry, 0.285714, 285714, 285714, and so on. Okay. Yes, one more division we are having. So after this problem I will explain the division. Note down these problems. Yes, ఈ సెకండ్ ప్రాబ్లంలో ఇంకొక ఫ్రాక్షన్ ఉంది 1/11. ఓకే, లెట్ మీ ఎక్స్ప్లెయిన్ దట్ డివిజన్. సో 1 and 11తో డివైడ్ చేయాలి. సో హియర్ డివిడెండ్ ఈజ్ లెస్ దాన్ ద డివైజర్. సో కాబట్టి నేను పాయింట్ వేశాను, 10 we can take. But here listen to me, still it is less than the divisor. In such cases, if you want to take one more 0 here, then you can put 10 in quotient part, then only you can take 10 in dividend place or dividend part. Now how many times it will cancel? Means 11 9 yes 99. What is the remainder? 1. Due to this point 10 you can promote, but still we need one more 0. But whenever you have been inserted one point in quotient part, only 10 is eligible to take. But if it is necessary to take one more 0, you can take one more 0 in quotient part, and then you can use 10 in dividend part. Now it will cancel again 9 times. 11 9 yes 99. Remainder 1. Due to this point 10. Still we need one more 0. That's why you need to put 10 here, and here also you can put 10. Again it will cancel 11 9 yes 99. Remainder 1. But here it is very clear to us the division is not ending. That's why you need to use the word non-terminating. And here the digits are also repeating and repeating in a particular order. So that's why you need to use the word repeating or recurring. So division is not ending, non-terminating, and digits are repeating. So repeating or recurring you need to use. Combinedly if you read non-terminating repeating decimal. That's all. Okay. Yes, 1/11 is equal to, how can you write that one? 0.090909 and so on. That's all. Yes, these type of decimals, if you observe, listen to me, 0.1 after all digits are repeating. So this is also a non-terminating repeating decimal. And here after 0 and the 0 point after 2585714, 285714, again you can get 285714. So here also the digits are repeating in a particular way. So this is also non-terminating repeating decimal. Next, here 0.090909, again and again it is the two digits are repeating. So these decimals are called non-terminating repeating decimals. So above decimals are called non-terminating repeating decimals. Therefore given fractions, what are they? Given fractions 1/6, 1 by 3 left for your homework. Next 2 by 7 and finally 1 by 11 or represent or representing non-terminating repeating or recurring decimals. That's all. Okay. Yes. Next, after that, this third problem I am taking. So in this third problem, first we need to write, that means here already have been given decimal forms, that all decimal fractions I am taking. So given decimals or first one 0.712, 0712, 00712, 000 and so on, comma, second decimal fraction is 101.01, 01001, 01001 and so on, comma. This is second decimal form. Next, given third decimal fraction or form is 123.1249631 and so on. That's all. Yes, listen to me. If you observe this all decimal forms and so on, we are having in 3 decimal forms, means the divisions are not ending in their respective decimal forms of divisions. Okay. So here and so on we are having, that means divisions are not ending. So whenever the divisions are not ending, such type of decimal fractions or forms are called non-terminating decimals. Yes, one more thing we need to add for it. What is that? Here 712 repeating, 712 repeating, 712 repeating. But here 10 we are obtaining between these two frames, and these two frames we are obtaining 2 zeros and 3 zeros. That means here the digits are repeating, but they are not repeating in a particular order. So that's why these are non-terminating, non-repeating decimals. So whenever we need to use the repeating decimal word in a particular order, if the digits are repeating only, we need to use that word. What is that word? Repeating. Otherwise we need to use non-repeating. Okay. So these decimal fractions are example for non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals are also called as neither terminating nor recurring decimals. Listen to me. Here also 01, 01. So here this frame is repeating 2 times. Okay. After that these two frames we are having 10. Next 01, 0001. That means the digits are not repeating in a particular way. So that's why we are having and so on. So non-terminating, and digits are not repeating in a particular way. So non-repeating. That means non-terminating, non-repeating decimal this is, or neither terminating nor repeating decimal. In that way also we can say. Yes. Come to the third decimal form, that is 124. That means first of all and so on you are having. So that's why this decimal form is nothing but non-terminating, because of division is not ending there. Due to that reason we are having and so on at the end of the digits, decimals. And here 1249631, whatever the digits if you have after this decimal places, they are not repeating in a particular order. So division is not ending, non-terminating, and digits are also not repeating in a particular order. So non-terminating. So this decimal is example for non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals are also called as neither terminating nor repeating decimals. Okay. So the above given 3 decimals or decimal forms, 3 decimal forms are example for non-terminating, non-repeating decimals are neither terminating nor recurring decimals. That's all. ఓకే, ఎస్, ఈరోజు క్లాస్ని క్లోజ్ చేస్తున్నాను. సో ఎప్పటిలాగానే మీకు నేను చెప్పేది ఏంటంటే మన ఛానల్ని సబ్స్క్రైబ్ చేయించండి. ఇంకా మీకు ఏమైనా డౌట్స్ ఉంటే అడగండి. ప్లస్ మీకు ఏమైనా మ్యాథ్స్లో ఇంకేమైనా అడిషనల్ క్లాసెస్ కావాలంటే కూడా మీరు నాకు కామెంట్ పెట్టినట్లయితే ఆ కామెంట్ నేను చూసుకొని మీకు ప్రొవైడ్ చేయడం జరుగుతుంది ఆ క్లాసెస్. ఓకేనా? ఎస్, కీప్ వాచింగ్. థ్యాంక్ యూ.